So my name is Samba. I'm from Career Booster Technology. So welcome back again to my video series. After going through some of the network essential topics, it's time to get into what we call as a TCP/IP model. Okay. So what is TCP/IP? It is Transport Control Protocol, Internet Protocol. So this is a topic which is like a bread and butter for any network engineer, because it is this model followed by everyone in the world when it comes to networking, especially the data networking, right? So it's all about networking, right? So let's begin with a simple discussion what a network is all about, or what networking is all about. So when I ask this question to a bunch of students in the class or participants, I get a lot of replies. All are true. There is nothing wrong in that. So for example, if I say, hey, what comes to your mind when I say network? People say it's all about information transfer. Quite true, because we upload information, we download information, irrespective of whatever the information type is. Then people say it's all about communication. That is also true. In communication, information does get transferred, but people try to see from more practical implementation point of view, from a technology point of view. They say that it's about connecting devices. Again, true, right? Because you have some server in US, a Google server in San Jose, and you are in India or some other place, and then you are able to get connected to that server, seek an information that you wish to see locally in your PC, so you'll be able to get, and that server there understand who is trying to request and then essentially connects to it, and so it is connected to several other devices. So it's all about connecting device, and through connecting device it also means connecting people, right? So there are many other definitions of, people say relations, I have my friendship built on the network. I have all my alumni and all my classmates of my graduation or school are together because of the network. So there are many definitions, okay? But being a networking technology course, we focus on the connecting part. So we say connecting devices and connecting people. Essentially, we are going to deal with what we call connectivity. So to set the focus right for this course, I am going to discuss about all the technologies which can make any device in the world which is capable of being on the network, which is capable of connecting to an internet, is connected to any other device, virtually irrespective of their geographical place or whatever is it. So this course whole thing talks about connectivity, connectivity, connectivity. How an information, when it goes out of a particular machine or a PC or whatever device is able to find its way to the destination, right? And how all the devices in between, maybe the routers and switches, are able to process this and understand who is sending this packet and where it needs to go. And in doing so, how does it connect to the destination accurately? How does it pass the information reliably? How does it know where to stop, where to end in terms of any session controls, or for that matter, even what media it chooses? Whether it's an electrical media, whether it's an optical media, whether it's a wireless media, these are all pretty well defined technologies, pretty well defined guidelines, or I would say protocols, which are embedded within the TCP/IP, right? So there's a lot of action that need to happen between the two devices which are located separately, so that the communication or the information transfer or whatever definition one might give for the network is actually true, or that purpose is solved. So let's stay with connectivity. That's my focus area for the training. So when I say connectivity, the first level of connectivity I see is a user-to-user connection. So when I say user, I don't mean really human user here. Like for example, I have a desktop computer, I have a printer, I have a server, I have a smartphone, maybe a laptop, or maybe a tablet PC or an iPad or whatever is it. And not to forget a router interface which will actually act like a gateway to your external world, the internet. They are all what we call as a users, and they're all connected to each other. The first level of connectivity we'll be focusing in this course is a user-to-user connectivity, where each user is connected to each other. So obviously when the connectivity needs to establish, they need to have identities, right? So one identity is IP address, Internet Protocol address, which could be in 32-bit format or 128-bit format. So 32-bit format is IPv4, 128-bit is IPv6. So I have a separate video session on that, so we'll go through that detail. But remember, in our numbering systems, we actually referred a couple of examples when it comes to converting binary to decimal, decimal to binary, and hexadecimal to binary, binary to hexadecimal. I referred a simple example of an IPv4 and IPv6 address. So that's the identity every machine will have. So you have each of these pieces like a desktop PC, printer, smartphone, server, and not to forget the router interface. Everyone has an IP address, and that's how they are identified. In addition to that, they have one more identity. We call it as a physical address or a MAC address, media access control, which I'll again refer in one more video, which actually identifies what we call the physical device. So each of these devices, okay, once they are supposed to be on a network, once they are capable of being on the network, they have two identities, IP address and MAC address. And that's how they identify with each other. It's like house numbers in a locality, right? How do you know a specific house is located somewhere? When you have the house number. So like they have an identity, and in that house there may be someone who is living there, they have a name. So everyone has an identity, that's how we are connected to each other. Now what is the thing that is about a few set of devices who are connected together and they have this what we call as a user-to-user connectivity? Some portion of their identity, especially the IP address, is common. For example, we have a locality ID. For example, if my house number is 10-100-by-1, okay, 10-100 by 1, and my neighbor house is 10-100 by 2, right? So we have something common. What is that common? The locality. So that if someone tells me this is where I live, and you see that his address and your address has the location portion common, what do you believe? You believe, hey, he's my neighbor. He lives within my locality. The simple reason actually is his locality ID and my locality ID are exactly same. The house number is different. So when it comes to devices within a network, one thing that binds them together is what we call as a network ID. So the network ID of this PC, network ID of this printer, network ID of this server, including the router interface, the network ID is common. Now there is some portion of their addresses which is unique to them, no doubt about it. Okay, so like our house addresses, if I have to repeat that, all houses belonging to a location have the same location ID, but their individual house numbers are different. So that's the reason we call this whole thing sometimes as simple as a network. So there are many names given to that and all mean same, because in the course I am going to use these words extensively. For example, people call it as a network here. They call it as a subnet. Some people say, no, this is not a network for me. This is only a portion of the larger network I see. Sure, that is also valid. So you have an internet which is connecting everyone in the world, right? So maybe that is a network for them. Out of which we have a small office, a home office, we have one small organization, maybe an educational institute or maybe a department, whatever is it. That is a portion of the larger network. So people try to remember it as one of the sub-networks. So we can call it as a subnet as well. And normally all the devices which are connected together, typically, I'm not saying always, typically will be physically co-located. Like in a house, right? So in my house, I have several devices which are on network at the same time, like my own laptop which I'm using for this training. So we have desktop too, and my family members have the mobile phones, and we have a printer, everything connected, right? So we are all in the same house. So we say that this is a local area network, so we call it as a LAN. And there is a concept called virtual local area network, or we call it as a VLAN, that also technically resembles as if the devices are belonging to one group. Definitely they have something common in them, which is the location ID. And the last thing but not least thing, these set of devices who are connected together are also referred as a broadcast domain, because from time and again you will have a requirement where you need to look for a particular end device. For example, I want to get connected from one PC to another PC, maybe laptop to desktop or something within the network. Once the devices understand that my destination identity and my own identity suggests that they belong to one particular local area network, then my destination is my next hop, right? If I have to send a packet from desktop to laptop, one hop I reach my destination. I don't have to go through any internet or something. In that case, to identify where this is connected, they typically broadcast saying that, hey, Mr. Laptop, where are you in the network? So they can afford to broadcast because that broadcast will reach all the devices, and whichever identity I am trying to identify through my broadcast will respond to it, and I get a connectivity. And trust me, the broadcasting is limited to a network only. So this is, you can't shout all over the world, right? Suppose you have a device somewhere outside my locality or outside my country, for example, there's no point in broadcasting it. That's way too much and it will really cause problems, okay? So in the switching protocols in the classroom, I'll talk about the broadcasting more in detail, okay? So I'll do that. So, but here, what you do is you actually limit your broadcasting always within a LAN, within a VLAN, within a subnet, or within a network if your definition is about devices which are connected together and having same network ID. So we also call it as a broadcast domain. So in the future, whenever you see this kind of a network, I may refer it as a network, I may refer it as a subnet, I may refer it as a LAN, I may refer it as a virtual LAN, I may also refer it as a broadcast domain. They all remain same. Okay. So what is one thing important in the users is you need to understand that the router interface here, which is a gateway to take to the internet, is also a user. So that also has an IP address, that also has a MAC address or the physical address. So the next level of connectivity is called network to network. So we saw these networks individually, right? So we have a network here which are user to user connectivity. You have a user to user connectivity. Obviously, we want to get in touch with every device in the world, right? Or every device everywhere. So obviously, when the device happens to be in a different network, then what happens? The router will come into picture, which is like a gateway. We will connect one network to another network. Now, like I said, in the LAN, we have identities which are IP address and the MAC address. That's how they recognize each other. And whatever device we are using to connect the devices typically identifies each of the users by their MAC addresses or by their IP addresses. The devices will understand by, understand the identity of each other by way of their IP addresses. Now in the router, what happens? It connects network to network. It's like almost like a national highway, like a highway, right? What a typical national highway or a freeway is all about. It's connecting one city to another city, right? So that's like a highway. So obviously, when you look at a highway, the identities is I'm connected to city A to city B. That's how we identify. We don't call that road is connecting one house to another house. We don't say that at a highway, right? So similarly, the router says, let me take the network ID of this and identify this network, all the devices with that network ID. Here also I have all the devices with a different network ID. So I am connecting two networks. And the identities of these networks in the router is all about their IDs. Whereas here within the LAN, the identities are the specific user IP addresses and then their MAC addresses. But here it's all about network IDs. So network A, network B, network C, that's how they get connected. So when you see the connectivity is at two levels, right? We saw the user to user connectivity, we have network to network connectivity. Now if two devices are connected together, if they happen to be within the network, then the user to user connection will establish the connectivity, and whatever your purpose, information transfer or communication is fulfilled. But in case you have to connect a device from within a network to another element in a different network, then obviously you need to take a help of a router. So here what happens, no doubt you have a server or PC getting connected to the router interface. So that's a user to user connectivity. and the router will connect this network to this network. So again, there is a user interface here, and then connecting the router interface to a PC here. So as a result of this combination of user-to-user connectivity and network-to-network connectivity, your device, whatever is it, it's like a PC or a server, is connected to any device in the world. And that's the kind of connectivity we are speaking about, right? So remember, again, I reiterate, this course is all about connectivity. And we saw two levels of connectivity. One was user-to-user connectivity. Next is network-to-network connectivity. In a simple words, this is nothing but we refer it as a switching. If a device packet goes from one user to another user, a PC to printer, PC to a laptop, PC to a router interface, this is all switching. Whereas a packet being forwarded from one network to another network, we call it as a routing. So that's the course is all about, right? Switching or routing or layer 2 or layer 3. So let me show you some of the sample topologies. I mean, we did discuss topologies in the Network Essentials modules. Now what I'm going to do is actually I am going to show you 3 levels of network, not with the details in terms of how many devices are connected and all that, but more like a concept, right? So what you are seeing on the screen is a simple small office, home office network. So where the main thing that comes to your mind when you see this is one single network. There are no multiple networks here. So you have a network here. So where you have PCs, you have laptop PCs, you have a server, you have the wireless devices connected to a gateway through what we call as a firewall. Okay. So essentially this is one single network. That means all the devices here, whatever may be, they all share one network ID. And they are connected to an external world, what you call through a gateway. So which is a router. Okay. So that's how it is. Okay, so that's about small office, home office, very small network, and the essentially whatever the devices, especially the networking elements, what you use, maybe the switches or routers, are typically either they are pre-configured, or even if they are configured, the configuration is very minimal. In other words, when I say small office, home office, it's all about accepting the default options. Whatever may be the defaults, you have an option. That means you have probably 20, 25 users or 30 users or whatever is it. You buy a switch with maybe 24 ports or 48 ports, depending upon your requirement. You connect all the devices, just connect them, power them up, and then use it. Whatever the Wi-Fi router your ISP, internet service provider, gives you, it's all pre-configured. What do we do at home? Typically, when we connect the wireless router, all that we just probably give a name to it. We call it as an SSID name and then give a password. That's it. That perhaps the only configuration we do. Otherwise, we just connect our PC. PC gets automatically IP address. It gets all the details. It is ready to be on the network. We just take a smartphone. We enter the SSID name, or we pick the SSID name, enter the password. We are connected. So that's the concept here. The small office, home office is typically a default as it is. Just plug in, use. That's it. Or plug in, play. We have to say that way. But if you move to a slightly bigger network, for example, a medium-sized network, then essentially what happens here is you have multiple networks. That means this is a larger setup or larger organization where number of people are used, and perhaps to relatively the dependence on the network is high, and it may happen that none of the services or none of the information or whatever is it may not be local to PC, but they're all hosted in a server. So you may have an email server, you may have a file server, web server, a lot of information is stored there. Maybe your code is there, your test plans are there, or test cases are there. And you may have a server which can allocate the IP addresses. You have a server which can translate what you call names into IP addresses, website names into IP addresses, and so on and so forth. and some of your devices may not be capable of constructing a protocol to make a communication possible. So you may have a proxy server which assumes the role. It understands one end you have a device which cannot implement internet protocols. Other end you have the internet, so this acts like a bridge. Classic example, if I have to take the olden days, is we used to have these VoIP phones, voice over IP, voice over internet protocol. When you have a typical normal digital phone which is not capable of generating voice over IP phone, you have a proxy server doing that for that. But essentially the requirement, the scale is bigger than a small office, home office, what you saw in the previous slide. So obviously you have multiple networks. So each network is supported by a router which is the gateway to it. But what is more important actually is you have some of the utilities like the file servers or DHCP or proxy, not to forget the external connection to the internet. This is common to everyone. So as a result, what happens, every network is connected to what we call as a backbone, and that backbone is in turn connected to some of the common utilities which all the devices, all the network elements here depend upon. So the architecture changes, so you need to have a backbone. On the backbone you place everything which is common to everyone, but isolate each network. This is one broadcast domain. Whatever that happens in the users here in terms of broadcasting should not come to any other network. That is limited to local. So that's how you divide the users. So essentially here is multiple network. So obviously you have a backbone connecting each of the networks to each other. And not to forget, on the backbone you have the utilities also placed, and you have an internet connection going through that, right? Now when I come to the enterprise level network, this is no way I'm suggesting the size of an enterprise level network. Enterprise network is pretty high, running into thousands of users at any time. But the concept behind any typical any enterprise network is the hierarchy. Remember I was talking about tree topology in my network essentials. So you have what you call an access layer where you have the end devices being connected. Distribution layer where all features are really built, like creating the virtual LANs or putting some security measures through access control lists to allow a packet based on where it is coming from or where it is destined to go. Based on a combination of that, you can either permit or deny any packet. You have what you call quality of service, perhaps giving a priority to the applications which are time sensitive, like for example a voice packet or any other online gaming or whatever it is. You can implement the policies on all here. So that's the distribution layer. Then you have a core layer where typically in addition to the quality of service, what you have essentially there is as a main function is the performance, because that is where it aggregates everyone. All the traffic is aggregated to the core, and from core it leaves to the external world. So here it won't be burdened with a lot of features, though it is capable of implementing a lot of features, but typically in a normal design, the core layer is all about aggregating them and then passing them over to the external world as many packets as possible in a given time. So normally millions of packets in a second, right? That's how they have looked at. So it's all about scalability, number of simultaneous users using it. It's all about performance, the time taken for it to process is as less as possible. So this is the focus there. So in an enterprise network, like this device could be multiple, right? So the access is a simple device, just giving a connection. That's it, no features, nothing. Distribution is all feature rich typically. And then the core is all about performance. So this is how we are connected. Now, during the courses, we will do a lot of experiments where you will get a chance to see the implementation of some of these networks. You will set up some servers, DHCP, DNS servers. You have what you call, even a web server you can put them, and then essentially see that how each device can reach out to this server, and you put it at a place where it's equidistant. Then you will see this hierarchical implementation, especially when I speak about spanning tree protocols and all that. So you know that they need to have a switch in the core level as a root switch, how each of them go travel the packet towards the root switch, what's the best path and all that. So you will see the examples of these three types of networks again and again throughout the course, right? But the idea is about understanding the concept behind it. So obviously a lot of things happen, right? Imagine a packet leaving your PC going all the way up to say some place in USA or any other country or another place within our country itself. So, okay. So a lot of things must be happening. It's no joke that every device in the way which is forwarding your packet understands where it is coming from, where it need to go. And not only that, it has to ensure that the packet is going to the accurate destination reliably and nothing should be missed out. And not to forget the performance and scalability requirements. So obviously they need to follow a specific model. Imagine if that model is one single piece of software, it becomes very complex, right? So very complex, one has to learn all of it and it is very hard to understand. And more importantly, from an engineering point of view, it is very difficult to implement any changes. And all of you who are into a bit of a programming must appreciate this, that when you have already established software, if you want to make any changes, either to fix some bugs or make some enhancements, it is quite complex thing to do, right? Because you don't know what change causes what side effects or what collateral damage it might cause. So it's very difficult. So the only answer for our kind of requirement where we see connectivity between any two devices, the packet which leaves the device must follow certain guidelines or must follow some sort of a protocol or a modular approach. So you divide the functions into several layers. Each layer has its own function. One layer physically takes it forward, another layer looks for the errors, third layer looks for the end addressing, fourth layer looks at the reliability. And the other part, like how do you present it, is a text code or a picture format or a video file. There every function, each of them focus on a different. So you have a modular approach is basically dividing a bigger task into smaller tasks. Obviously it is less complex, easier to understand, easier to implement. I often take an example of a constructing a house or a building, right? Can you think of the number of jobs that need to be done in constructing a building? And frankly, whenever one of the videos I typically watch in YouTube is how they construct these massive structures, like all these skyscrapers all over the world, whether it's in Gulf or whether it's in Malaysia, Petronas Stars, or whether it is the US, Chicago, all those towers. You really see the documentary, you will understand that it is no way one person or one department can do, right? There are many people. Someone does civil construction, someone does the, what do you call, the electrical part, someone does the water pipe sanitation, someone does the interiors, you name it, there's many people. And each of them are specialists in their own. No single person is capable of doing everything. You may say that the top level architect knows everything. Sure, he knows everything. The building architect knows, but he depends on many people, right? So that's how this works. So in the networking, when a packet has to go from one place to another place, you have a lot of functions to accomplish. Better divide them into smaller tasks and make them handle, make them implemented through an individual set of specialists rather than one guy taking everything. And also whenever change you may want to make any changes, you can make change that because it's highly modular. The changes are limited to that only, so it won't impact any other things. So the scope of work, the scope of the code in which you are trying to make any changes, either to fix a bug or make some enhancements, has a limited scope of any collateral. So that's why it's much easier to work, right? Now to demonstrate this, let me show this. And if you are an Indian, you are pretty familiar with this, right? This is the earlier part of our, if I say networking, if I have to say. So remember in the networking slide, I said it's all about information transfer, right? Connecting to people and all that. This was the means. It's a postcard, a 15 paisa postcard in India, right? So what does this postcard contain? It has a lot of message. People say that, hey, I have a message to send you. I'm coming over to your place at so and so date. I remember I wrote many such letters. But what helps this letter to go forward is the address. So I'm writing my own address here. So this is my Bangalore address. So my name is Samamurthy here. So there is a building number there, and then there is a indication that I work from the 4th floor. This is a building name. I have a street address. I have a locality. Of course, I have a city, which is Bengaluru, which is the name of Bangalore. And I have a pin code. Who is filling this up? I am the one who is filling it up. For example, someone is filling it up if they have to send a letter to me. Okay? But if you notice that each information here is written essentially to ensure that whoever handles this letter forwards it to the right place. Like for example, if I say pin code, suppose someone is posting this letter from another place, say from say Delhi. Okay? So when someone posts in the Delhi, the postman picks it up, and what makes him believe that this should go to Bangalore? It is the pin code, perhaps the city name or pin code. The locality street address may not help him at all. The name definitely doesn't help him at all. I'm not a celebrity here that people know my address automatically or at least know where I live. Obviously, the information the postman depends on is this address, right? And then once it reaches Bangalore, someone looks at the locality. So that makes him forward further. Someone looks at the door number and delivers it. Once it reaches my office, if some of my colleague picks the letter, what he or she will see? Will see the name. So when you put this information, each piece of information is for someone to interpret and forward. Remember, once the letter is posted, every person till it reaches the intended person. For example, unless until till the time it reaches my desk or it is in my hands, everyone does one simple job. What is that? Forwarding. The postman in Delhi forwards it, and then postman in Bangalore forwards it. If this letter falls in some other hands in my office, they'll forward it to me. So we really see the purpose here. This is read by the end recipient. The final recipient will see. When I see my name on it, I'll read the letter. All others are not supposed to read the letter, right? So they say they just forward it. Oh, it's not me. I have to forward it. Similarly, the locality is read by the local post office at the destination, that is in Bangalore. And this is something read by the local post at the origin. Now, what I'm trying to say, am I trying to teach you the postal system here? Not exactly. I'm laying a simple foundation for the TCP/IP discussion here. You remember here, there is a portion in the letter where you are supposed to write a address. And there is a specific way you write the address, right? You put the name first, then you put the building number and the building details, and then you put the street address locality, then you put the city, and then there is a space specifically meant for pin code. And why we have to fill that? Because everyone will see that way only. They expect you to write that way. And whoever is forwarding obviously know where to see what. And in a lighter vein, like a joke, for example, imagine if someone interprets the pin code as a house number or a building number. What will happen? The letter won't go anywhere, right? So it has its own place. So we follow knowingly, unknowingly, whenever we send a courier, whenever we post a letter, we follow a protocol. Even when we are sending email these days, we write very less letters compared to olden days. But when we are sending an email, what do? There is a space where we write the destination email address. There is a place where we write the subject. There is a place we want to copy someone or blind copy someone. And then there is a place we write the actual content of the message or the message content. Knowingly, unknowingly, we are bound by a model. We are bound by a rule. The simple reason actually is once you follow the rules, this letter or this packet, if I have to say that way, can find its destination irrespective of who interprets it. Right? Now our discussion on the TCP/IP model is essentially based on this concept. A concept of what is that I need to ensure that, I actually put information well enough so that irrespective of whatever path it takes, whichever router or switch it may go through, everyone will know exactly how to forward it further. So that your message hops around probably different routers, maybe 10 routers, 12 routers, or 13 routers, I don't know how many routers and how many networks it may pass through and reach the destination ultimately. Simple reason is your own PC follows TCP/IP model. Every device on the way follows TCP/IP model. Your end machine also follows TCP/IP model. So that's the foundation for the TCP/IP. So in my next video, I'll talk about the details of the TCP/IP. This is more like laying a foundation for you. Okay. Thank you and see you in the next video. Thank you.